In parallelogram A, B, C, D, AB is equals to AD. So AB is equals to AD. So I like to add AB is equals to AD. Now, if we are told that it's a parallelogram, again, we can now add now, because we're told that it's a parallelogram. So this side here is actually parallel to that side, and that side here is also parallel to that side. And again, this side here will be equal to that, and this one will also be equal to that, because these opposite sides should be equal. So I'm just saying you can just put those what called down, then you won't have a problem. Now let's now go into the question. Calculate the size of all interior angles. Now we need to now know, we are given AB, okay, C is equals to 110. Oh, good start. So C is 110. Now, when C is 110, let's calculate A, which is easy here. So we know that A is going to be equals to 110. Why are we saying 110? Opposite angles of parallelogram equal. Now, okay, what's next now? What's next? What we also see is that when we look at at angle here, this one 110, we can also find D1 and B1. Okay, we can also find B1 and D1. Okay, so this we can now say, okay, B1 is equals to D1. Why are we saying that? Because these are angles opposite, equal sides. So where do we use this when we are dealing with an isosceles? Okay, so when you're dealing with an isosceles, you know that this is what you're supposed to deal with. So it's either when you're given the sides that are equal, you can safely say angles, they also equal in that case. So here, let's indicate that they are angles, okay? Now, what can we now say? We can now find B1. So B1 is going to be equals to 180 minus, minus, it's going to be 180 minus 110 divided by 2. Let's see that. 180 minus 110. Okay, we divide that by 2. We can get 35. So here is 35. So what we now see is that we now have 35. We now have 35. But now, when I have that 35, so it means that B1 is equal to 35, and also D1 is also equals to 35. Then what can we also say that B2 will be equals to 35. Why are we saying B2 is equals to 35? Let me put it in this way. Let me put it like this. B2 is equals to D1, which is equals to 35. So now we now have what call B2. Let me not write it together like that. It's therefore B2 is equals to 35. Why are we saying B2 is equals to D1? Alternate angles. Why are we saying alternate angles? So alternate angles are equal. But where are we getting that? We are getting that because AD is parallel to BC. So AD is parallel to, to BC. Why are we doing this? Because this is a parallelogram, we are given that. Okay, so once they are parallel, we have then alternate angle, the Z angle that we see there. That shows that D1 is equal to B2. Okay, now what else are we left with? So we are now left with what we call D2. What we can say is that BAD is equals to BC. Why are we saying AD is equals to BC? AD is equals to BC. Why are we saying is equal to BC? Opposite sides of parallelogram equal. So now we can also, since these two are equal, your DC is equals to AB. Okay, if your DC is equals to AB, then we know that these are also opposite sides of parallelogram equal. So now when we have that, we can now say, okay, if these two are equal, we know that AD is equals to what is it? AB there as well. So it means that BC, therefore, BC will be equals to CD. Now, once we have BC equals to CD, this makes what? This makes an isosceles. So when we have the isosceles, we can now say D2 will be equals to 35. Why are we saying that? Because these are angles opposite equal sides, because we have proved that this is an isosceles. This side here and this side are equal. That's why we are saying what called D2 should be also equals to B2. That's what we mean by that. Okay, so in this case, we just prove that B2 is equals to D2. Okay, that's what we need to know. So in this case now, we now have all the angles that we wanted. So 35, so 35, and also 35. That's what we have done there. Now, let's look at this one as well and see. ABD and BCD, ABD and BCD are two isosceles. So we are told that there are two isosceles triangles, okay? So when there are two isosceles triangle, we know what happens when